Systematic studies to check for the presence of oil or gas are carried out by oil companies before the decision to drill an oil well is taken. This systematic study is known as prospecting. While prospecting for oil, geologists use a wide variety of techniques like gravity, magnetic, and seismic surveys to help them pinpoint the exact location of oil underground. Prospecting for oil is a long and laborious process that could take anything from a few months to a few years to complete. Prospecting for oil starts with the preliminary geological studies of the area. Available literature and remotely sensed data in the form of satellite imageries and aerial photographs are studied. Satellite imageries taken from orbiting satellites are scanned views of the Earth's surface. These images provide views of very large areas, such as a sedimentary basin or even entire countries. These imageries enable us to study very large-scale geological features which are often missed in surface geological mapping. Aerial photographs are taken from an aircraft and provide a large-scale bird's-eye view of the area. Aerial photographs are shot systematically, looking vertically downwards, and have an overlap. Photographs with an overlap, when studied with a stereoscope, give three-dimensional views of the geological structures of the surface. Subsequent to these preliminary studies, detailed geological surveys are carried out. Such studies help us to understand the age and nature of sediments, the environments of deposition of the various sedimentary layers, and the structure of beds, and any occurrence of natural seepages in the area under study. After the surface data has been obtained and carefully analyzed, the next step is to carry out airborne gravity and magnetic surveys. A gravity survey involves the precise management of the gravitational pull, G, at close stations along the track using a very sensitive instrument called the gravimeter. Positive deviations from the regional average indicate heavier rocks, whereas negative anomalies imply a relatively lighter rock. A grid of such survey line allows us to map the anomalies across the area. The analysis of these anomaly maps give us an indication of the underlying rock types and structures. Magnetic surveys are primarily carried out to calculate the depth of sediments in a sedimentary basin and to locate major structural features within it. The principle used in magnetic surveys is based on the fact that different rocks have different magnetic properties. Those that have relatively higher magnetism cause very small effects in intensity and direction of magnetic fields. These effects are measured and mapped in a magnetic survey. Since most of the magnetic materials are contained in igneous or metamorphic rocks, the relative strength and sharpness of magnetic anomalies is controlled by the depth of occurrence of these rocks. Since these rocks usually constitute basement, the depth below the surface can be interpreted as the depth of the sediments in the basin. Both of these surveys generate a considerable amount of data which is helpful in the narrowing down of the location. Subsequent to these, a detailed seismic survey, either refraction or reflection, is carried out. Seismic surveys can be either two-dimensional or three-dimensional. 3D surveys are extremely expensive but yield a considerable wealth of data. The two most commonly used seismic techniques are the reflection and refraction surveys. Both of these techniques use the principle of travel time of sound waves through a formation. In reflection surveys, a small charge is exploded in a shallow well called the shot hole. Receivers, or geophones as they are known, are placed in a straight line on either side of the shot hole. Energy from the blast spreads in different directions, and a part of it travels down through the subsurface. Wherever it encounters a change in density of rock, it gets reflected upward and gets recorded on the geophones. This process is repeated across a series of stations along a survey line. In a refraction survey, a similar technique is used, except that the distance between the shot hole and geophone is very large, and that the travel time of the refracted waves is recorded. Refraction surveys give a large-scale picture of the area as compared to the reflection surveys. Data obtained from all these surveys is collated and analyzed to yield an exact picture of the subsurface structures and their geometry. This helps in pinpointing the exact location to be drilled. However, all the surface exploration work done is only indicative in nature, and the final test is the drilling of an exploratory hole.